I'm trying to share screen so I can like open up the issue links. Yeah, Eric, does it come out?
Yeah, yep. I got it. I can see it.
Eric, I was going to ask you, which I forgot earlier. One of the issue in here was about multiple certificate configured for Notary V2. Have we validated that we actually support multiple certificates?
I mean, I don't know that we have tried it. I think in theory we do.
Okay.
Since we do have in the config, it's represented as an array, and in the plugin, it loops over the values of the array to load them into the certificate pool. So yeah, in theory we do. I don't know if anyone's tried it.
Okay, so I tried this. I have two images, one signed with certificate A, the other one signed with certificate B, and validation on both succeeded. Does that, well, it must mean that Notary have taken both cert in and was able to validate.
Yeah, if you had a single configuration file with two items in that array and you did that, then it worked.
Okay, cool. Does that mean we can close this issue?
Let me see which one you're showing. Investigate. Yeah, yep, that can be closed.
Okay, I'll add a note to with my test, and then we can close that.
With the yeah. I was going to say with the caveat that it's not nice. I don't think there's like nice support for it through the Helm chart. So if you were to go to like the Helm chart values and try to add a bunch, I don't think that would work. Yeah. But like Ratify itself, yeah, it works.
Yeah, you have a separate issue tracking and like adding multiple certificate for the Helm chart.
Okay, then yeah, if there's a separate one, then we can close this.
Yeah, I think there is. Let me double check. That one, add support for, oh, sorry, that's auth provider. This one, multiple notation certificate within Ratify Helm chart.
Cool. Yeah, then we can close that other one.
Okay, great. I like closing issues.
Yeah, it's nice. They seem to grow. Issues grow.
It's now, we have 2 pages now. Okay, are we expecting Sajay today or Nathan?
That's a good question.
Probably not Nathan, because I think the handoff is right now for on call. So
I see.
Yeah.
And do we need Sajay for anything, or can we proceed? Like, I'm just wondering if I should ping him.
We can probably we could probably carry on. And unless he has something to share.
Yeah, sounds good to me. Oh, we also have Luis joining today. Luis, would you like to say hi? Eric, I don't know if you met Luis.
Hello, Eric. Let me see if I can start my video. Hey. Yeah, I'm just here. Susan and Akash are both working on Ratify. I'm just basically trying to ramp up and sort of understand kind of what's going on here in this space. So I'll be crashing in a couple of these meetings. Okay, cool. And you're I am a dev manager in the ACR team. I see. Okay, cool. Okay. Nice to meet you, Eric. Nice to meet you.
Okay, everyone can see my screen, and I think I will try to populate the agenda before our meeting. So maybe on Fridays, like if you have anything to discuss for the next coming week's agenda, just populate it. So I feel like if people are interested in joining the meeting, if we actually have something on the agenda that they're interested in, they're more likely to join. So one of my goals is to have it with some items to discuss before the Tuesday meeting. And today, I know last week we talked, Akash and Sajay and Jimmy and Teja talked about the Kubernetes secret authentication provider. And I read, Akash, your notes about the cluster binding and the role binding. Do you have more details?
Yep. So I can kind of give a quick rundown because I don't think the others are here right now. But basically, the idea is we had discussed adding the Kubernetes auth provider, which is kind of cloud agnostic. So the way it would work is that in the config, you would specify the secret name and map that to the actual registry host that the credentials match to. And then Ratify would take the Kubernetes secrets, extract those, and then use the credentials from there to actually pass to Auras and authenticate and pull from the private registry. So last week we were talking about kind of from a user perspective, how would we scope and restrict the permissions the Ratify pod would have in actually reading the secrets in the cluster. Because in order for Ratify to actually read the secrets, it's got to have the permissions to those specific secrets, but we also don't want it to have access to maybe all of the secrets in the cluster. So with that in mind, that's why we were kind of discussing the whole role-based authentication scenarios where you could set up a cluster role, and that cluster role would be defined to be given permission to basically read secrets in a namespace. But because it's a cluster role, the role is defined across the cluster. And the actual binding, which is the role binding, would be defined on a namespace and a user/service account level. So for each namespace that we want to allow Ratify to access, if we have secrets in those namespace that it needs to access, the user would manually create those role bindings, which would bind the cluster role to the specific user service account that Ratify uses. So that was kind of the scenario we were talking about last time, and actually Jimmy was very helpful in discussing the pros and cons on that. Since then, Teja had also recommended looking at how Google Crane actually does their own Kubernetes keychain credential providing and how they kind of scope access. And so I was able to take a look at that, and they actually leverage something called image pull secrets, which essentially are a list of secrets that you can define in the actual pod spec. And it basically tells the pod that for any sort of private registry authentication needed, all of the secrets that hold the credentials for those registries are stored in this list of secrets. So what that, from a user point of view, what that looks like is that a user would create either a basic authentication secret or specify like a Docker configuration secret, which contains, the host to credential mappings. And then in the actual pod spec or the deployment template, they would specify a image pull secrets list with all of the names of the different Kubernetes secrets that the pod needs to use to grab the registry credentials. And so when the pod starts, since you've already defined the list of secrets it needs access to, you can use the core V1 API to actually read those secrets, and then Ratify can do its thing. So it makes a lot of sense actually to do it that way, because that's kind of the most scoped down access, most restrictive. So the user of Ratify would basically have to create the secret and then manually specify those list of secrets, which it's a one-time thing, it's a setup thing, so it shouldn't be too big of an issue. But I think that's probably the way forward we're going to want to tell users if they are going to use the Kubernetes secret provider, if that makes sense. Any thoughts?
I could see one, I don't know if it's a problem or if it's just a paper cut, but one thing I could see is at least for, for Azure's managed experience, you can at the cluster level associate with a registry, and then you don't have to define pull secrets for every container because it happens automatically. So that's one thing where, if we did it that way and then people didn't specify pull secrets and then they were confused, that would be one. And I assume EKS has probably some similar mechanism where you can link up a cluster to a registry, but I guess that would be one minor con, maybe. And then you said the other way you had mentioned was, or Jimmy, did you have something on that?
So, yeah, excuse me. So for EKS, we're gonna, we try to use as much upstream Kubernetes as possible. So we would be using image pull secrets for that type of thing. The thing that I was talking about last week with respect to cluster roles versus cluster roles using role bindings, maybe I misunderstood the way things were happening here, but I thought that there would be an SA, a service account in each namespace. But if you're only using one service account for one pod in the, let's say the Ratify namespace or something like that, then the cluster roles with namespace scoped role bindings is not going to work. So it would have to be a cluster role and a cluster role binding because you have to skip across those namespaces. So if image pull secrets are the way to go, I'm fine with that. That's very least privileged way of going at things, I guess.
Yeah, from a deployment perspective, I'd imagine Ratify would get deployed similar to the way Gatekeeper does, where Gatekeeper is typically deployed in its own namespace or in the kube system namespace, and Ratify would probably live next to it. So it would have to reach across to all the namespaces where stuff gets put.
The only use case that I'm worried about, or I don't, maybe I don't understand the use case in general, but at a cluster level, if there was a use case such that certain tenants on a cluster did not use the same image pull secrets, then how would we resolve which pull secrets to use, I guess?
You mean
her tenant?
For the same registry, they'd have more than one, like having more than one credential for the same registry within a cluster, or having... Could be. Or are we saying that they can only use one per registry per cluster? Those are some boundaries I think we need to understand. Yeah, that would make sense. I guess that would depend on the model that you'd go with. Like, I think the easiest model would be, for me at least, it would be one image pull secret matched up to one registry. And yeah, like I don't know that in Azure's case there's even support. Like, you could have more than one credential with access to the same registry, but I don't know if you can do anything more fine-grained below that. Like, oh, this credential can only pull repos ABC or something like that. And that's another question that we need to, and I can go back and talk to our ECR folks, but it could be that because registries, hold repositories. So it could be that, image pull secrets are granular. I don't know if they are at the ECR level, if they're granular enough to not only get to the registry, but also restrict from what repository images can be pulled. Yeah, I think at least in our initial implementation, the assumption was that there would be whatever credential, we would have one credential that Ratify would use to talk to one registry, or, you'd have one for each registry, and that would give you access to whatever you would need from the registry. So if there was a use case of more fine-grained, there was RBAC within the registry associated with individual credentials that multiple teams had, and they all deployed to the same cluster in different namespaces, then it gets weird. So I didn't know if we had gotten that far.
Is it possible to start with one credential per registry and then expand on that?
I would say that's probably the best choice. Would be to assume that there's one.
Yeah, but we'll have the implementation so that if needed in the future, we can support multiple credentials.
Yeah, like if we were going to support multiple, we would just be like when some deployment happened, or when, you know, we would either take it from the image pull secret of the particular deployment that was being audited, or you would take it from the secret in the namespace. So, as, you know, as long as it would just come from whatever was provided by the audit request or the deployment request, then it would work.
Yeah. And I think that's also a good point, that one registry can have multiple potentials, potentially multiple credentials, because Akash is working on, like, I saw an item for label matching for the authentication provider.
Yep.
Does that also take into consideration the not just matching the labels for registry, but also repositories?
So, I mean, we could alter it to consider that too, but I think we were considering at the registry level, not at the repo level. So.
Got it.
Yeah. And I think the way ORS's authentication also works, I don't think it accounts for the repo level either. So I'm not sure how, even if we have specific credentials that we can differentiate at the repo level, at the end of the day, we're relying on ORS's authentication to use those credentials. So if it's not distinguishing between the different repos, then yeah.
I mean, I would assume it would not be an ORS thing. It would be like a backend thing. Like like the same 2 different credentials you could use in ORAS requests to the same registries for get manifests for like images. If you just wanted to dump out all the images, the same call with different credentials might return different results if there's RBAC at the repo level within the registry.
I see what you're saying. Yeah.
Yeah. And that also with the stuff we talked about for like caching, like look ahead caching for the timeout thing, that, I mean, this applies to that, because as soon as we're considering that case where, you know, oh, we think we've already cached this whole registry. Well, it turns out people are backed it and we only cached half of it because they don't have access to the other half. So yeah, I think the initial assumption was one credential to rule them all, and it has access to the whole thing. So
Jimmy, is it a common usage pattern in EKS or ECR that people have like one set of credential have different access to the repository?
Yeah, I mean, a lot of the access to ECR is done via identity and access management. So you could have, so for instance, let's say I'm running a pod, or I set up a deployment that's going to be using a service account, and, you know, for that pod, but the credentials that are applying that change to the cluster, they have their own set of IAM credentials, and then you've got the pod itself that can use it as, you know, a service account. And then we use something that's called IAM roles for service accounts. So it's a way of giving the pod itself its own specific identity and access management credentials via a role that users don't get to, and the actual underlying nodes don't get to. It's actually just for the pods. So in that sense, you could, you know, have access to, you know, the ECR registry, but you would not have access to all of the different repositories.
I
So
see.
you can lock down the repositories, and it's also dynamic. So let's say I have a Claire scan, or maybe even an AWS inspector scan, and it comes back with a bad scan. I could lock down that repository from being allowed to vend images. So yeah, but yeah, your question about multiple credentials is correct. I'm going to find out if we support. I haven't even looked at if we support image pool secrets. I think we do, but I haven't seen it. So I'm still looking.
Okay. Yeah, I was gonna say I don't know if we do at the repo level. We might. I haven't looked through all the documentation, but I know you can have multiple credentials to the same to the same registry with different levels of permissions, like from a pull or push perspective. I'll have to look at how granular you can be on the ACR side, but
yeah, we have token-based repository-based access, Akash. So for ACR, we haven't implemented the AAD's Active Directory level support, but we generate tokens and password based on, you can create a scope map. It's a type of object where you can say, define the repository and what type of access to the repository. So you can have content read, content write, for example, and then you can generate tokens, which are just username and password, and you can assign the token to the scope map. So that's kind of like similar to the role binding for ACR.
I see. Okay. I see.
Yeah. So, but traditionally, we only have the admin user that would give you access to the entire registry. And AAD currently only supports the entire registry access, but there is the token-based access that would give you repository-based access. Oh, something just refreshed. Yeah, okay, Akash, so you're going to continue looking into the image pool secret?
Yep. Yeah. So I'll continue looking into that. I think from an implementation wise, it doesn't really change because at the end of the day, we're reading in the secrets. What's going to change is how we, like the documentation and the guides that we provide the user on how we recommend they install it in their cluster and use it. So I think that I need to look into, and then maybe we can discuss again next week what we all think about that. Yep.
Yeah, sounds great. Thanks. The next item I have is on the list is dynamic configuration. Eric, you want to talk about it?
Okay, cool. Sorry, my computer is telling me it was doing weird things. Yeah, so for this one, this is how we're going to go about enabling dynamic configuration. So there's obviously having to redeploy Ratify every time you want to change something, be it from a plugin perspective, you want to add a new public key to notation, or you want to add a new check for a verifier. Like let's say you have SPDX verifier for SBOM, and you can have it check licenses and you want to change the licenses that it checks or something. We need a way for it to be able to update on the fly, so that you don't have to redeploy everything for it to work, and also so that for configuration management tools, you might want to just change CRDs or change one thing and have other tools be able to modify Ratify. So we had this issue a while back. One of the first things we talked about, but I think Teja here gave the 3 things that we had looked at. And this was just sort of bringing up like what people would think about different approaches to this. I was starting to look into the Kate's CRDs, since that's how other tools like Gatekeeper uses CRDs extensively for configuring constraints and regos, and now with external data providers. So that one would be, it's a lot more work to implement that. There's a lot of boilerplate from the extension or the example that I looked at. But just if people had any other thoughts about how we might go about this, or what would make the most sense. And if there's no opinions, you know, I can keep going down the CRD path and maybe give an idea of what that might look like. But, you know, just in case people had any thoughts about how, you know, you might want to interact with this, maybe is a REST API the right way? Is a file watcher the right way? Is CRDs the right way? Or if there's opinions.
What's the advantage of CRDs over file watcher?
I think the advantage I would say is that it's more of a native Kubernetes experience. So you would get more of you could use more stuff from the ecosystem to manage the deployment of those CRDs. Like if you had Helm charts that included the resources that your application needed, you could add those resource definitions to your Helm chart. And it would be, I guess it's just that. And then, you know, Ratify would manage the getting the state to the desired state on its own. And it would probably, I would think it would give you more granularity. Like with the file watcher, I think that was just like the first cut, like the easiest thing would, you know, we could just have something watch the configuration file. And as soon as it, you know, somebody changes the config map, you know, it would say, oh, I'm updated, let me go fix myself. But I think it's less like the control over that's more interesting because you're modifying one file for like 10 different things. And so it might be hard to track different types of changes that different teams might want to make in the long term. You'd essentially be layering patches on top of each other. So, and then the experience we have today, which is the blow it all away and put it back experience. So the one thing I'd say about the Kate's CRD choice is we would have to just be cognizant of the way that we implement it being friendly towards still running from the command line. So whatever we do needs to still support, you know, the use cases that we have today, which is somebody running from the command line or people who will put this in their CI pipeline, as well as, you know, running in the cluster. So.
Yeah.
I was just bringing this up because this was something that I had thought was very interesting, and that now like it makes sense for us to look at it again as people start to look at how they can consume this, and if they're actually like if people are going to deploy this, we'll need a better experience than redeploy it. So.
Jimmy, do you have any experience with CRDs? Wondering if you know any like unknowns issues.
So, I mean, CRDs are the other part of operators, right? I mean, so an operator's controller that's has an extended through CRDs, right? This is basically the way that I see it. And so I look at it as CRDs are great when you're wanting to provide a native approach to Kubernetes that also extends the API. So like Gatekeeper does it. And so you can still use tools like, you know, kube control to update the Gatekeeper templates and constraints because, you know, the templates themselves and the constraints themselves are actually underpinned by CRD. So it's a great solution, in my opinion, other than sprawl. When I look at one thing that I'm always trying to be cognizant of is, are we introducing another operator and CRD? Are we creating operator sprawl? So That's the only concern I would have. But I mean, I like the approach to CRDs, and I think it's the way that most custom configurations go when they want to be able to leverage the native interface into the API server, right? So be able to reuse the Kubernetes API server request flow by applying changes to an element that's underpinned by CRD. It makes sense to me.
Yeah, from a sprawl perspective, I was thinking of where else this could come from, and I don't know if in our case we could like plumb through anywhere else that I'm thinking of to expose that. But yeah, I do agree that having some like oh, let's build a cluster and then let's install 3,000 operators on it. Like that's I always think about that. And I'm like, oh.
Yeah, well, I mean, I think a lot of people don't understand. People that are writing operators, sometimes they're really good at it and sometimes they're not so good at it. And their operator, while it may work, it may overtax the control plane. And so that's another reason to be leery about having so many operators in your cluster. That being said, as long as we follow best practices on how we create the operator and how we're watching and we're not overtaxing the control plane, then I mean, I think an example of OPA Gatekeeper being so successful with their CRD approach, that's very positive. And if you also look at Caverno, you can actually do explain, a kubectl explain on Caverno's extensions and get a response back from there. So, I mean, that moves Caverno, closer to, not necessarily in the tree, but very native to Kubernetes, the Kubernetes experience at least. So I think looking at these three, I think redeploying the pod is not something I'd want to do at all. The file watcher maybe, but I mean, I think I'd start with the CRD. I think I like that the most.
Cool.
I mean, we're already talking about writing a controller, right? I mean,
Yeah.
So
yeah, I mean, it's for all intents and purposes, that's sort of what it is, but we hadn't implemented the way you talk to it yet. You just give it everything up front and then, so.
I think if we're wanting this to become more and more native look and feel to Kubernetes in general, then I think the CRD is probably the way to go, in my opinion.
Cool. Yeah, I'll see if I can. I'm gonna think about what that interaction would look like from a resource perspective, and what a schema might look like for some of them, and hopefully have something to show either next week or the week after, so that we can decide if that looks like a good idea or not. and then we can move forward on implementing.
Great, thank you. The next item we have is I created a new issue for the verify behavior when there's no signature on the image. Eric was telling me that if there is a SBOM on the image, the verification will pass even without a signature on the image. So I logged an issue and we had a discussion about, should we specify like a minimum passing criteria for each plugin. And I see the dynamic configuration. Teja also added a note about this, that we need a policy that enforces the presence of a signature for every artifact. Eric, is that related to the dynamic configuration?
Yeah, sort of. So that I think part of that dynamic configuration is that the config, there's there's like three sections, right? There's the plugins, there's the verifiers, there's the verifiers, the refer stores, and the policy. And I think this is explicitly calling out, dynamic config. We should be able to change the policy. The second part, I think, starts to bleed into like policy implementation. But yes, we need more policy than we have today. We have the bare minimum amount of policy that you could call policy. So yeah, I think part of the confusion, I think, comes from the implementation in the executor. Right now, if you don't have any verifiers, like if no verifiers run at all, it fails. Because it returns failure with no verifier results. But if you have one verifier that's configured and you have an artifact for that verifier, then it's a pass fail, right? The artifact either passes or it fails. And then it seems like it works as expected. But as soon as you have two, then it gets weird, because if one works and the other doesn't, it's still, or if there's an artifact for one rather, and there's not an artifact for the other, then it will work. And so this is just around, does it make sense to remove that default behavior that we have that says if there's no verifier results at all, should that be considered a failure?
Well, I mean, so are we onboarding to the verifiers via some namespace label? I mean, how's the whole onboarding of image lookup to begin with? Is it a cluster wide thing? Is it a namespace level thing? How are we opting in to do the verification in the first place, to call, Ratify and to use the verifiers?
That can be decided at the gatekeeper level. I think our chart.
Oh, okay. So it'd be like a gatekeeper constraint using like an array of namespaces. Okay, well, that makes sense. All right, if it's a gatekeeper level thing, then we could just say, hey, this constraint has an array of namespaces, where you could have one constraint per namespace, or you could have one constraint with multiple namespaces. That's how gatekeeper works. So now after that happens, to me, is there any granularity to say, I mean, if I'm looking for image verification, I don't care about an SBOM. As a matter of fact, that's noise to me.
Yeah, if you're at runtime, you probably care less about the SBOM than you do about the signature verification.
Yeah, I mean, if the policies themselves, if the gatekeeper constraint template code is going to be written such that it can also verify signatures on SBOMs, that's one thing. But for me, the very first, let's say the MVP for this, I think, would be verifying signatures on images.
Yeah.
And then, so to me, if I get an SBOM or a signature of an SBOM, I don't care about that. That is noise. I want the signature attached directly to the image itself.
Right. And so today that does work. If you have a signature attached to an image, we'll validate it. And if it's a valid signature, you'll get a pass. If it's an invalid signature, you'll get a fail. I guess the question was around our current implementation is a little ambiguous, because if you configure the notation plugin, I guess your intent is that you're checking that something is signed by that signature. But if you look at an image that has no signature, you could still pass it.
Yeah, and I'm not sure. So this is starting to get to like the whole fail open, fail close scenarios. For instance, gatekeeper itself can be configured to fail open or fail closed.
Right. Yeah.
Right. And if it fails open, that means that for whatever reason, if gatekeeper doesn't respond in 3 seconds, then the change goes through anyways.
Mm-hmm.
If it fails closed, then no changes will go through if there's no response, but it also may brick your cluster. So to me, if I opt in, if the constraint is such that my namespace is included in that constraint, that means that namespace it's opted into doing this verification for image signatures, and no image signature can be found, then to me that is a failure. And then that pod cannot pull that image, or that pod cannot go forward because the signature is not there.
Right.
As to me, not having a signature on a, if not having a signature available for me to verify is the same as a failed verification if I'm trying to verify signature.
Right. Right. So I would agree that if you configure a notary plugin, the intent is that images should be signed, and thus if you don't get any artifacts, if you don't get any notary artifacts, then you'd consider that a failure. So we'll have to figure out how we actually address that from an implementation perspective, because the executor it just loops through all the generic verifier plugins, not knowing what they are, calling their interface, but then it will,
Eric, can we maintain a map to say, basically saying you have to have a signature on the subject where it's the image? Then we kind of in the loop, we'll just check it off once we see it.
Yeah. So when we because in the executor, what happens is you loop through all of the artifacts that are associated, and based on their type, you check the applicable verifiers. So as part of your policy, you could add an item that just says if there are, if the notary plugin is configured, you must have a root level artifact that is of this type. So which is the type that the plugin's configured for. So here, like your application notary v2 signature, your part of our policy would just be if that plugin is configured, which it almost always is, then you have to have a the first level has to have one of those. So I guess that wouldn't be too hard to change.
So if all things being equal, and I'm really brand new to this, so I apologize if I get something wrong here. If Ratify is installed on the cluster and configured properly, and so the verifiers are accessible via the policy that's going to run via a gatekeeper template, and the gatekeeper constraint that uses that template specifies the namespaces that are in scope for this, then we're assuming that so I guess, are the policies that are the gatekeeper constraints and templates, are they specific to image verification, or are they open to other artifact verification?
They're open to any verification. So I guess the idea for Ratify was that we would keep, from a gatekeeper perspective, we would try to keep the policy very lean and handle as much of it within Ratify as we could, so that it would be more portable. Like if you wanted to swap out Caverno, we wouldn't have to re-implement all sorts of fancy policy logic from gatekeeper in whatever Caverno's analog is for it. Mm-hmm. So then that portion would be lean, but that then we have to make sure that we handle whatever amount of complexity somebody would want to have within Ratify, and then make a nice way for them to tell us what the policy should be.
I mean, I can understand the desire to not have to have one-off solutions for each of the policies code vendors or projects out there. However, from a user experience, I would like to know that the policy that I've put in place handles image signature verification.
Right.
And I mean, However, that's done under the covers via the implementation details. At the end of the day, what all I need to know is that it is image verification and what that means. Well, like for instance, from a coarse grain perspective, I get a signature back and that's verified, or there's no signature available, so the two failure modes are no signature available or a signature that's not verified. So otherwise I'm verifying a signature and that allows me to pass with this policy. However, I mean, if you can do that, however the implementation works, that's fine. But at the end of the day, when I add this policy to my cluster, I want to be able to say within this constraint, I'm including these namespaces so that every pod in that namespace will now go through image verification.
Yeah, I
So
think
under the
that's
covers, you guys need I guess we need or I say we, but I mean, I'm not really writing anything. Need to write it in such a way that it's true that we are doing image verification and not some other artifact verification, image signature verification and not some other artifact verification.
right. Yeah, that's the plan, is that if whatever configuration mechanism we come up with, if you include notary and you include a certificate, that we will be doing that validation, and anything else you might add in your configuration will be extra. So,
I mean, later on, are you saying that maybe they also want to look at SBOMs for a particular image and that would use a different verifier? Is that what you're saying?
yeah. So in the configuration that's on screen right now, there's two that are configured. There's the notary one, which has that public key there. And then there's the SBOM one, which checks a different artifact type. And then the SBOM one also has a nested reference, which is a signature. So this configuration would support checking signatures on the image as well as SBOMs, which themselves are signed. So what would the
use case in the Kubernetes cluster be for verifying an SBOM signature?
There might be some metadata that is, you might have some metadata in there that you want to look at. The first use case that we've actually implemented, so this SBOM example was fairly lean. Like we just put some JSON in there and checked it, but there is actually a license checker verifier that you can run that verifies that all the licenses from all the artifacts in the container are of certain license types. But
it seems to me though, would that actually be a Kubernetes use case or just a CI/CD automation?
Yeah. And so that's where that might not necessarily be a runtime thing that you care about, is checking that. You might have that as audit, for example.
Yeah.
But the idea is that you could run essentially the same configuration or some subset of a configuration in CI, and you can run, the same thing in the cluster. So if you were to run, like, let's say in your CI, you had a validation step at the end where Ratify checked that stuff got signed and that all the licenses were okay, etc. You could use the same configuration there as you would use in cluster. So that was one motivation, but I'd agree. Like most people probably once you're in cluster, all you care about is that it's signed. So,
I mean, I guess another reason for having the policy explicit enough that it's a policy written for signature verification of an image. If you do decide that you're going to expose additional use cases via different verifier calls, to me, that would be different policies at that point, different constraint templates, different constraints. Or maybe you could write it in such a way that you reuse the constraint template, but then your constraint itself becomes a little bigger, and now it has different parameters that you can pass into the constraint template. But it's so that the user experience is, at the end of the day, for me, the user experience is primarily captured in the constraint itself, not the constraint template. So,
yeah,
because most people are not going to be writing Rego. I mean, that's the whole idea behind Open Gatekeeper, is to reduce the amount of Rego you have to write and then use constraints instead of having to write Rego.
Yeah,
So,
and that might mean that at least in our case, like, yeah, we could write a bunch of constraint templates and then let people make the constraints. But then that goes back to the, well, what's Caverno's version of constraint templates? Is it the, I don't know if it's, I've only looked at it enough to know that it exists and that they kind of support external data providers. But
so is it documented? So I guess where would it be documented so that we could take that to the Caverno project and give them an idea of what's going on here?
the
interface between Open Gatekeeper and the Ratify verifiers?
The Gatekeeper, I'll see if I can find a link, but the Gatekeeper project, I think they have a page at this point that talks about external data. So I'll see if I can find that and get a link. And if I can, I'll post it somewhere. But yeah, they have some docs about how it works and how you set it up with constraint template.
I mean, because I know the external data thing is kind of new. I mean, it's been around in OPA for a long time, but it's kind of new to Gatekeeper. So
it's very new, yeah.
And so being able to use it in Gatekeeper and understand maybe the pattern of how it's used with Ratify, if that's documented somewhere, then I can take that to the Caverno folks and at least give them an idea of what we're looking at. And
yeah, it would be. I'll find the link, but the high level is you essentially tell Gatekeeper as part of the constraint template, you tell them the URL, the in cluster, it can be out of cluster, but you tell them the URL essentially for your external data provider, and they send you a blob of JSON, you do some stuff and you send back a blob of JSON, and then the Rego happens against the blob of JSON you return.
Yeah. Okay.
So that's the high level. And when last I looked at Caverno, they did have a mechanism where you could say, oh, check this external thing, but the external thing had to be, it wasn't like a request response pattern. It had to be a static external thing that was like native Kubernetes. So like they said, oh, you can check a config map, or you can check essentially some API server driven field you could have Caverno check, but your application was responsible for keeping that from keeping that fresh. And so, I didn't know if they had any mechanism where Caverno could tell you, I'm about to look at this. So I don't, last I checked, it didn't seem like it worked in quite the same way, where you could have it explicitly depend on something else. But you could tell it to check other things.
Okay.
So.
Well, I mean, at a minimum, we can show them what we're doing. I mean, I think Caverno is also doing some work with Sigstore and Cosign. So they may be going down a different road, at least for now, but at least if we can show them the interface of, for how what the pattern looks like for how Open Gatekeeper is going to consume dynamic, at this point in cluster URLs, then they can decide what they want to do with that.
Yeah, that makes sense. Okay, let me see if I can find that.
Sorry, I didn't mean to go off into a rabbit hole.
All right, found it. If I can figure out how to paste. So I threw it in the chat here, and they're very happily proclaim at the top that this is the alpha.
Oh, okay.
But yeah, they go through in here how you can go about enabling it. And
also they talk about providers and provider implementation. Okay.
Yeah.
Okay.
So.
Jimmy, back to the policies. Do you think we totally agree that the verification should ensure the signature exists. Do you think it can be something implicit, or should we add another policy block to make it configurable? Just like how you mentioned, gatekeeper can fail open or fail closed.
Well, yeah. So, I mean, this would actually be independent of gatekeepers' failure modes. But for me, it's a matter of, I mean, you can make it an implementation detail that's not exposed and say, you know, if I try to verify a signature and either the signature doesn't verify or there's not one for me to verify, then to me, that's both a failure. And if you want to implement it that way, that's fine. Off the top of my head, I don't know where that use case would not fit for everybody, but you never know. I guess my concern would be, right now we're trying to hit a specific use case. It sounds like where we're using a open gatekeeper policy, which essentially is a template and a constraint to verify image signatures. Beyond that, if there's additional use cases, to me, that's new policies. So like a different, at a minimum, a different constraint, maybe the same constraint template, maybe not. Because in the constraint template is where you actually physically write the rego, where you would actually make it looks like the external data call and interpret the rego coming back. So, I mean, you could, essentially, it's like writing, I don't know. I mean, I'm a Java developer by trade, so, and I've done a little bit of Go, but essentially it's like writing an app, you know, a REST client to hit the same REST endpoint over and over. And then the functionality of that endpoint changes just based on the data you push it. So I guess that will work. You would just have to write your Rego in such a way that it knows. It's one thing to say, I'm going to send you this data, but it's a whole other thing to say, I'm going to get back this JSON payload. Now I have to parse that JSON payload and apply rules to it to make sure that it passes. To me, that's going to get a lot more complex. If it was the layer of, to me, the layer of abstraction here is the OPA gatekeeper constraint template. So I think it should be written in such a way that if I want to reuse my constraint templates, I can. If not, I can write a completely different constraint template for a completely different use case using the same external data calls either to the same resource or to a different resource provider inside the cluster. So, or outside the cluster for that matter, I guess. I'm not sure if I answered your question, but I mean, to me, that layer of abstraction is, you know, the policies themselves, the templates and the constraints. And to me, I'm not sure why you wouldn't want them to be as expressive as possible so that any future use case could be just done by writing a new constraint template and constraint.
Is the constraint about reading the response from the external call?
No. So when you look at a constraint template and a constraint, if you look at it just a regular like validation constraint template that doesn't call external data, all it does is it gets the Kubernetes API server request payload, and then it matches a policy to it. And then like to make sure that it's doing the right operations. And once the policy is matched, then it uses rules within the same policy to make decisions about that inbound change. So this is going to be very similar. The only thing that changes here is that you're making an external data call to verify signature. Other than that, I mean, it's essentially it's the same thing. So to me, when you write the constraint template, that's where you write the actual code that does all the evaluation, that it does the validation of this piece. It just so happens that in this particular implementation, it's also making an external data call. So I envision the policy to be written in Rego in the constraint template in such a way that I'm getting ready to, I'm getting a pod or a deployment spec that's coming in, and or for that matter, anything can create a pod, right? So deployment, a job, whatever. I'm getting those things coming in, and I'm going to detect that it's either a create or an update, or and I can specify what operations I wanted to look at, create or update, and then it's going to make an external data call if it gets a signature. So for instance, it may fail even before it gets makes the external data call. So that's the part that, we haven't talked about either. There may be a failure use case that doesn't even require an external data call to ratify. So, but I guess what I'm getting at is, to me, how we customize future use cases should just be, I've got another provider endpoint within my cluster that I can use. And so I might write a new template. The template itself is where all the Rego goes, does all the validation. The only thing the constraint does is it says, here's the namespaces that this policy will apply to. And so the constraint points to the template, and it says, for this template, here are the namespaces I want to apply this to. And then you can also set up properties within the constraint template that can be set up as parameters in the constraint. And then the constraint itself can pass input parameters to the constraint template as part of the whole input. So, but you can think of the constraint as a way of focusing down the policy on a specific namespace or a specific resource type or a specific version, or, and so on and so forth. But all the heavy lifting goes on in the constraint template.
Yeah, thanks for the information. I will take a look. Eric, do we have any samples for constraints in our repo, or is it some samples in the Gatekeeper?
Yeah, we have a constraint template and a constraint that we have defined as part of our chart that uses external data. It's pretty lean. So if you want like a more complicated one, Gatekeeper's documentation has a pretty good amount of it.
Yeah, there's an actual really good OPA Gatekeeper library. So OPA Gatekeeper has its own GitHub repo, and then they have a whole separate repo for a library of policies. And then you could start to see the difference between templates and constraints. I mean, in the grand scheme of things, you could have one template that is the foundation for multiple constraints.
Yep. Yeah. And if you want to play with it, I will say that I've already done a decent amount of it, but like doing the Rego is pretty inaccessible. Like the easiest I've had is to take the input that you would get from the external data. When they call the external data provider, you can take that input and you can just go to the Rego playground. There's like a website where you can write Rego and have it get applied to some arbitrary data. And
yes, so I've done a ton of Rego, so I might be able to help there. And I write policies for us all the time for the EKS best practices guide. So I mean, I can help there with some examples, but is there a link to where you're
like in our
is it in the Ratify?
Yeah, so if you go into, let me check. If you go into charts, which chart do we use now? We had to, our chart situation is kind of weird. So we had to split it up because there was the ordering in which you install the stuff is important. But there's not really a great way to configure that. So if you look in the Ratify Gatekeeper templates, you can see the constraint there. And then I think under charts, let me see, charts
Ratify, and then what is it called?
So under Ratify charts, Ratify Gatekeeper.
Ratify Gatekeeper.
There is a templates constraint. And that's the constraint that exists for the demonstration. And then
Yeah, but where's the underlying template though for this constraint?
yeah, I want to say it's in the other. Yeah, it's in the other. I'll paste the link.
Okay, I'm looking in here. So ratify templates.
It's in the other chart actually.
Oh, it's not in that chart.
So yeah, so Ratify Gatekeeper is it includes Gatekeeper with external data provider on, and it includes the constraint. And then the Ratify chart includes Ratify and the template, which is the bottom one there.
All right, so I'm looking in charts. Bottom one is ratify. And then if I look in the templates folder.
Not the template, there's the template YAML.
Oh, the chart YAML.
Yeah. So you can see Susan has
That's
the
not in here.
on the screen share, she has the path up there.
Templates. All right, hold on. Ratify templates, template YAML. Oh yeah, okay, now I see it.
So there you can see our Rego's pretty simple here. All it does is call external data and look through the response for invalid.
So response equals external data, and then we're passing in where the provider is the ratify provider, and the keys we're passing in is, and that's at this point that's the digest, right?
That I believe so.
Okay.
Yeah. I'd have to look at like
Yeah, I think I've seen this before.
includes.
Yeah.
But then yeah, you can see. So it's a very this check is lean because it's literally just like looking for like a specific error message that Ratify sends back. So we could have Ratify essentially run through its whole song and dance and just return a very verbose data structure back to Gatekeeper, and then write very complicated Rego and very complicated constraint templates. And that would suffice. However, then this tool wouldn't work in CI because you don't have Gatekeeper in CI. So that's sort of where
And so the issue, I mean, I guess we're at time, right? With this, we're over at 8.
Yeah, we're over by a bit. So
but the issue you had was that you couldn't apply the constraint because the template itself didn't exist yet. Is that what the issue you had?
Yes, yeah. So we had to have people install things. It isn't all bundled nicely in one chart because the order matters. You install this, and then I think our docs say to go to that other chart and ignore the chart and just install that one file.
Yeah, because basically, if you look at the constraint itself requires that the template already be in place because it's that kind.
Yeah, and Gatekeeper has the same thing where they need CRDs to exist before they can put stuff in place.
Absolutely.
And they do a lot of fancy advanced Helm stuff to make it work. And if you uninstall Gatekeeper, the chart does leave some stuff behind. So because it just isn't supported. So we do have items.
If you delete a template, for instance, if you delete a constraint template, it will delete the constraint as well. Right.
Yeah. But if we put the constraint in this chart, there's no way to tell Helm to do it in order. It's going to do whatever it does. It just renders one giant file essentially, and then K applies it. So there's it, and then it bombs out because the template doesn't exist before the constraint. So
okay.
So that
Thank you for taking the time to explain it to me.
Yeah. So that's another item. We have an item on our list to make the Helm experience nice. Right now it's not nice, but that's not entirely our fault. So
cool.
Yeah. Yes, we're at time today. Thanks for explaining all that, Jimmy and Eric. Yeah, before we wrap up, is there any agenda item for next week that I should put on the board so we can prepare for that? Eric, is there any item that you want to discuss next week?
Yeah, if you want to put on there that we'll to take a look at the CRD stuff, I'll try to have some like an outline in place where we can say, okay, here's the type of resources we want to support. Here's the data that they might hold, etc.
Sounds
Yeah,
good.
and then I'm gonna show this constraint template that makes the external data call. I'm gonna show that to the Caverno project folks and get
Cool.
their feel for how they want to look at that.
Yeah, that'd be awesome. And if you, I did post a link in the chat if you are able to open it, that shows what they do support, what Caverno supports right now as far as external data sources. So
Yeah, that's great. We'll look forward to hearing from you, Jimmy.
Yep.
Yeah. All right. Thank you for joining, everybody.
cool.
Yep.
Thanks all.
You guys.
Thanks, everyone.